Okay, so good morning from me. My name is Apostolou and I'm coming from Greece. So we heard a lot about the clinical outcome. I'm a molecular biologist, so I will see the hyperthermia from this side of view. Today we're going to see together how can we use the study of circulating tumor cells in order to predict the response to hypothermia. So the question is, can we use the liquid biopsy not only for prediction in chemotherapeutic drugs or other kind of therapy, but can we use these for predict thermotolerance? This is what we're going to see side by side today. First of all, we're going to discuss how the hyperthermia and cancer are correlated, but from the biology aspect, and of course the heat-soaked proteins that are involved in this area. After that, we will discuss the method we use for detect and isolate circulating tumor cells, and finally the result we have from our study. So let's begin. We heard a lot about hyperthermia. In the biology field, we know that heat-soaked proteins are important in hyperthermia with many ways. They express usually after a shock. This is the temperature. So we have increase of their expression. They make complex with a lot of peptides, so they can increase the sensitivity of the immune system. And this is the one way they can attack to cancer. The disease that can recognize the new peptides can prime the T cells, so we can have increase in the immunity. Otherwise, we know that heat-soaked proteins are correlated with protein folding. So we main our study in 3 heat-soaked proteins. We know that they are named according to the molecular base. So we have the heat-soaked protein 27 or HSBB1. We know that it's correlated with cancer, and of course we know that it's a protein that can inhibit the apoptosis. That's why the expression of HSP27 is correlated with resistance of cancer cells. A similar situation for HSP70 or HSPA1A, also correlated with apoptosis and other parts involved in cancer. The last one is HSP90, as you can see, implicated in all hallmark traits in cancer, from angiogenesis, metastasis, invasion, migration. So the study we have performed is mainly performed in these 3 proteins. Now let's go back to the liquid biopsy. What is liquid biopsy? We have heard a lot about that. And our purpose is to give you information about circulating tumor cells. Circulating tumor cells are cells derived from the primary tumor. The primary tumor is not a homogeneous population, it's a heterogeneous, and we have the cells, the circulating tumor cells, that have metastatic ability, renewal ability. And we have also proved that inside the circulating tumor cells might be involved a subpopulation, which are the cancer stem cell-like cells. So these cells can derive from the primary tumor and throw through the bloodstream and can generate another metastasis. The process that is incorporated in this is the epithelial to mesenchymal transition and the opposite. Up to now, there are many techniques for detection of circulating tumor cells. They are usually based on future characteristics or morphological characteristics of these cells or the expression of specific markers. We have to keep in mind, however, are the cells, after all these techniques, viable? Can we study further these cells or not? And of course, do we have only circulating tumor cells or other subpopulations that can make or increase the noise are incorporated in this one? The platform we use is based in a flow cytometry. It's a very common technique. We have the blood, we start from blood, and we're using specific markers or specific selection, and we start with negative selection. We can identify any specific population we need. We use forward or side scattering to identify the size of the cells or to eliminate parts that are not cells but maybe express something. And with different fluorescence or fluorophores, we can identify anything. We base first on negative selection in order to eliminate undesirable cells, and then with specific eliminations, we identify and isolate viable the cells we need. We can do this by using specific characteristics in the flow cytometer we have. We try to have 1 droplet per cell. We can play with the values of the cytometer in order to have viable cells. Up to now, we have the ability to increase this method with a specificity of 83.9%, which means that we can identify a positive sample with this specificity. Or the sensitivity is 82.6%, which means that when a sample is negative, 82.6% we can identify that is negative. No CTCs can present. So now let's come to our study. We involved 180 patients. We took blood samples from them, either from Europe or USA. The majority of them were breast cancer. You can see the 31%, but also any type of other type of tumors were involved. There was performed enumeration of circulating tumor cells. The most methods incorporate only enumeration. Yes, we know that the increased number of CTCs is correlated probably with metastasis or the poor prognosis, but this is not always true. We don't need to be focused only on the number of CTCs, we need to study them. So, as you can see this slide, in colon cancer we have very high expression of a very number of CTCs, the same is sarcoma. But if we go further and see, are these CTCs have higher or lower expression of heat shock proteins, we're going to see something different. In breast cancer, 12% of patients were resistant to hyperthermia, which means that they were overexpressed heat shock proteins, at least 2 of the proteins that I mentioned before. If we go to pancreatic cancer, we see that we have increased percent, that's 70%, while in ovarian, 20%. And if we go to the colon cancer, and keep in mind that in colon cancer, in the previous slide with CTCs number, we had the highest CTCs number, we have the highest resistance. But also keep in mind that no prostate cancer cell line, prostate cancer sample was resistant in this one, or the sarcoma, in which we observe high rates of circulating tumor cells. So it's not only the number that gives us information about the sensitivity in any kind of therapy, but also the study of specific proteins in this. So to conclude, we know that heat shock proteins correlated with resistance. And we know that the circulating tumor cell is one important thing in liquid biopsy. With the technique we have, we can identify CTCs, and we believe that in combination of not only enumeration of circulating tumor cells, but also the study of specific hallmarks they have, could be more benefit for the treatment, not only in chemotherapeutic, but also in hyperthermia. Thank you for your time and patience.
Thank you. We have time for one question.
So you have roughly 1 CTC per milliliter. How many do you need to do your analysis?
The limit of detection. How?
How many do you need for your detection, for your analysis?
For the analysis, we usually start with 2 ml of blood. 2 ml blood. Yeah, we have the limit of detection, and we know that probably in 1 ml of blood we have from 8 to 10 million total cells. The CTCs are very rare, but the limit of quantification and limit of detection we have established in our method are very low. We can identify the limit of quantification is 1.4 cell per 10 million of total cells, while the limit of detection is 4.5.
If no more question, we can close the session. Now we have the 15 minutes coffee break. And thank you.